A DNS query is where you, yes you, interact with DNS the most. It is the most meaningful part of the DNS system because it is the part that originates in your daily experience of using the internet or your local network. Every time you type www.lynda.com into a web browser and press return, you're initiating a DNS query. Every time you send an email, you initiate a DNS query. So what happens when you do that? Well, a DNS message is sent that contains a header that indicates that your query is a question and not a response, first of all, and whether the request should be considered a recursive or a non-recursive request. The query also includes a question that contains the domain name that you're querying or that you're asking about. It includes the class of request, which will probably be IN or internet-based, and a type. And that type tells the DNS server what kind of information you need, like whether it needs the reverse of the name or the IPv4 address or IPv6 address, or if you need to know where to send mail, for example. When all of that hits the DNS server, it formulates a response. Now, the response will also include the header and question section, just to keep track of the original request, but it's going to add the answer to your query. The answer will include the information that you need, or if the DNS server doesn't have the information you need, the answer may contain a referral to a DNS server that will be able to help you get the answer. That makes sense, right? I mean, if you ask a question of a person, that person is either able to answer your question or not. And if they can't answer your question, it would be helpful if that person could tell you where to go to get your answer. That's essentially what's happening here. The DNS server either knows or it doesn't know. And if it doesn't, it is sending you along to the next most likely place to help you complete your query successfully. If the server does know the answer, it'll send you back the resource record that contains all of the information you need. This concept of resource records is important because a resource record is what we call a set of DNS record information. An A record is a resource record. An MX record is also a resource record. So if you ask for the IP address associated with www.lynda.com, the answer is going to look like this. Now, this particular answer tells us that the information we need to resolve our request actually leads us through a CNAME record because www.lynda.com simply points to another server. Then, of course, the DNS server knows that we can't do anything with that CNAME record because it's still just a name and we need that IPv4 or IPv6 address to actually go somewhere. So it sends us the information about where that referred server is located, which gives us the IP address we need. So you can see that there. The first line is the answer section. The second line is where it's telling us lynda.com goes to this alphacdn.net server. And then that tells us that that's going to redirect to that, which goes to another in. And you see that A right there that goes to the IP address 192.229.162.23. Again, this would look similar but have different information for virtually any kind of A record lookup. And we're going to play with that a lot more later on. We'll show you how to use DIG and network utility and other utilities to do this type of lookup and get this type of answer. Of course, this isn't limited to web browsing. As I've said before, we could be looking for how to get mail sent to Sean at dancechoreography.com. There's another example of a domain. So we'd be asking for not only the MX record information for the domain dancechoreography.com, but then when the DNS server realizes that we need mail.dancechoreography.com, it goes ahead and finds out where that server's located, which results in the IP address for that server. And that answer looks like this. As you can see here, we have our question section followed by our answer section. While we can see all of these things and pick them apart using DNS tools like DIG or NSLOOKUP, the key to understand here is that this information is passed around every time your applications need to resolve a name that you've placed into your settings in, for example, your mail application, but also your calendar application or contacts and any other application that asks you to put in the name of a server into your account settings, right? And that's going to be on a computer or an iPad or a smartphone or whatever. From that point forward, every time that application contacts that server, it starts off by initiating a DNS query. Now, making DNS queries is not something you usually do purposefully, but DNS requests and answers make traversing the internet for services you use a constant part of your life. And hopefully, now you understand that process a little bit better.